going to end right on time. The last little bit that we have to talk about is what happens with an acid and a base when they combine. Treat them just like ionic compounds and do a double displacement reaction. That's a good review from back in chapter 7 when we had two ionic compounds that reacted together, like sodium chloride and silver nitrate. Okay? Plus, minus, like that, two reactants. Do you remember what you do to figure out the formulas of the products when you have two ionic reactants? What do you do with those ions? You got like plus, minus. So then what do you do to make the products? Yep, you switch those ions around to make new plus, minus pairs, right? So when we've got HNO3 and calcium hydroxide, the ions that we have for an acid are H plus and whatever the minus was. Okay. What would calcium's charge be in this compound right here? Yeah, because you got two hydroxides, so that helps you, but it's an OH minus. Okay. So we're going to make new ion pairs. So H plus will end up paired with what? Okay. And what do you get when you pair up an H plus and an OH minus? Good old hydrogen hydroxide, right? Dihydrogen monoxide, maybe? Yes. H plus and OH minus combine to form water. And what phase label do we almost always give water at room temperature anyway? Yeah, that is the one liquid phase label we use. Okay. Acids are all going to be AQ. Soluble ionic compounds are going to be AQ. Okay. What is going to be, well, let's do it this way. What's going to be the name of the other product? Yep, it's going to be calcium nitrate. Okay. It's going to be, leave room for a coefficient. It's going to be calcium. And then how do I write the formula of calcium nitrate? Yep. Why do we need those parentheses there? Because we need two of those nitrates. Calcium's charge is 2 plus. We're going to need two of these to make that neutral. That's going to be AQ. Let's do a quick balancing here. 2 nitrates, that's the easiest thing for me to spot. That tells me I need 2 there. Okay. And then we can probably just add up H's, right? Because nothing else has H over here. Those both have O, so let's add up H's. 2 H's there and 2 H's there, so I have 4 H's. So what do I need in front of water? Yeah, so then it's balanced. So this is a neutralization reaction. We've got a strong acid and a strong base. And if we add these two, if we added 2 moles of that acid for 1 mole of that base, they would neutralize each other perfectly, and we get water and a neutral salt. Okay? The ionic product of a neutralization reaction, that's what a salt is. Really just an ionic compound, but that's where the word salt comes from. So mixing together an acid and a base in the correct proportion will give you a salt and water. So you should try to predict the correct balanced chemical equation for these ones over here. It requires writing the ions out, swapping them and making the right products. That will be, I will have that in the notes that you can download, okay, if you want to check your work on that. Okay. But after you do that, we're done with our notes and our class. So come and visit in the lab if you still need to do a cleanup task. We'll do studying and questions in the lab, 8 to 10. You can come during any portion of that time. Return a calculator if you borrowed one, please. Thank you. And we'll see you.